Hello students, in this video we will learn more about factoring trinomials with a leading coefficient that is not equal to 1. Now we're going to look at two methods for factoring these trinomials, and our first method is trial and error. That is, we're going to reverse the process of multiplying two binomials. Okay, this strategy requires trial and error to find the correct arrangement of coefficients of the binomial factors. Here we go with example 1. Factor each trinomial completely. Now, if there are some things that we know for certain, we will put those in place first. For example, we see that these are all plus symbols in our trinomial. And so we know to use plus symbols in the binomials. Also, we know that 5 is a prime number, and so our first terms must be 5x and x to get a product of 5x squared. Now it's a matter of placing our factors of 3 in the appropriate places. So we can either put the 1 first and the 3 second, or we could place the 3 first and the 1 second. Now we check and see which of these is correct. In both cases, we obtain 5x squared, and in both cases, our last product is plus 3. So really, we're only concerned about the sum of our inner and outer products. In the first example, 15x plus x is 16x, and that does not work. In our second option, 5x plus 3x is 8x, and that one does work. So our correct factorization, 5x plus 3 times x plus 1. And this is the process of factoring by trial and error. As we consider part B, if this trinomial factors, it's going to factor a product of two binomials. Now we're going to consider many options here. Factors of 10 are 1 and 10, 2 and 5. Now factors of 6, and that's a negative 6, isn't it? So we know that when we place these in our final factorization, they need to be differently signed. But for now, I'm just going to consider the factors 1 and 6, 2 and 3. Now I want to think my way through this a little bit. If I try to combo the factors 1 and 10 with a 1 and 6, our inner and outer products are 1 and 60, or they might be 10 and 6, and neither of those combos leads to 11. If we combo 1 and 10 with the 2, 3, we can have products, inner and outer products, 2 and 30. Okay, that's not going to achieve 11. Or we might have 20 and 3, and that will not achieve 11 either. So I don't believe we're going to get to use the 1 and 10. If we try the 2 and 5, say 2x with the 5x, can we place a 1 and 6 in there? Okay, now I'm not putting the signs in yet. We know they're differently signed, so we'll end up subtracting our inner and outer products. Can we consider 5x and 12x via subtraction to obtain 11? No. If we switch the 6 and 1, 30x and 2x, we can't subtract those and obtain 11 either. So I don't think we're going to get to use the 2, 5 with the 1, 6. How about the 2 and 5 with the 2, 3? Can we place 2 and 3 in here? 10x with a 6x, we can't subtract those in either order and obtain 11. How about the 3, 2? 15x with 4x, that is going to work as long as the 15x carries a positive sign and the 4x the negative sign. Now let's check this completely. 10x squared, outer product negative 4x, inner product 15x, that sums to 11x. And 3 times negative 2 gives the negative 6, and that's going to check out. And this is the process of trial and error. Okay, we consider all of the options, and we do our best to find the one that works. In part C, if this factors, it's going to factor as the product of 2 binomials. Now, there's something that we do know about this one. As we look at our last term, that coefficient is 1. Therefore, we know that our last terms have to contain, each of them, the variable b. Now, they are going to be differently signed in order to obtain a minus b squared. So that much we know. Now it's just a matter of placing our factors of 6a squared in place. We know that each of these will contain the variable a. And let's see, I'm going to try a 6 with a 1. If we try 6a with 1a, let's check. Product negative 6ab. Inner product is plus 1ab, and those combine to negative 5ab, which gives our middle term. And this is going to check out completely. We got pretty lucky on that one, didn't we? In part D, trinomial, if it factors, it's going to factor as the product of 2 binomials. And let's look at this and see if there's anything that we can determine right off the bat. Well, our last term is 2. 2 is prime. Its only factors are 1 times itself. Additionally, that last term is positive and the middle one is negative. How can we obtain a positive product yet a negative sum of our inner and outer products? Those terms must both be negative. So this much we know. Now it's just a factor of getting our factors of 10 in the appropriate spots. And we know that there will be a variable x with both of those first terms. Now, do we use the 1 and 10 or the 2 and 5? Okay, remembering that we definitely want to obtain an inner and outer product sum of negative 9. So I'm going to start with the 2 and 5. Can we try a 5 up front and a 2 at the back? In other words, negative 10x minus 2x, does that give negative 9x? No, it does not. What if we switch those? 2x in the front, 5x in the back. Outer product is negative 4x. Inner product, negative 5x. And together those combine to negative 9x. And there's our winner. Again, be sure to check these completely by multiplying in order to ensure that you have factored correctly. Now, our second method that we're going to consider is a factoring by grouping method. And in step 1, we'll multiply the coefficient of the squared term by the constant. In other words, we'll multiply our leading coefficient by that last term and find the product AC. Next, we'll find 2 integers such that their product is AC and their sum is equal to B, our middle coefficient. We will rewrite the middle term, bx, as a sum using integers from step 2, and then we'll factor by grouping. And some people call this the MARF method, wherein we multiply, we find 2 values that add to that product, we rewrite the trinomial, we factor out the greatest common factor, and we factor out a common binomial. Well, let's go back and factor the previous problems using this factoring by grouping method, method 2. So let's consider our first 4 examples. So I'm going to come right back to 5x squared plus 8x plus 3. Now, step 1, we're going to multiply these outer coefficients. 5 times 3 is 15. Now we want to find factors of 15 that sum to 8. Okay, 8 is that middle coefficient. So let's just walk ourselves through the factors of 15. Like 1 and 15, they sum to 16. 3 and 5 sum to 8, so those are the two that we want to use. Next, we're going to rewrite this trinomial as 5x squared plus 3x plus 5x plus 3. So we've kept our first term, we've kept our last term, and this middle term we just split into pieces. 3x plus 5x is 8x. Now the hard part is over. We factor by grouping. In our first two terms, factor out x. In our second two terms, just going to factor out 1. So you can see this repeated binomial factor 5x plus 3 and factor it out to the front. 5x plus 3 times x plus 1. And notice that this is the same factorization that we got previously using trial and error. Let's work another one in part B. The trinomial 10x squared plus 11x minus 6. Step 1, multiply your outer coefficients. 10 times negative 6 is negative 60. Now, here's the only hard part. Okay, here's the only part where we're kind of using a trial and error as we find factors of negative 60 that sum to that middle coefficient, 11. Now, negative 60, its factors must be differently signed, like 1 and negative 60 or negative 1 and positive 60. These aren't going to work. They sum to negative 59 and positive 59. What about 2 and negative 30? No. Negative 2, positive 30. No, these factors are too far apart, but we're getting closer. How about 3 and negative 20, negative 3, positive 20? Nope. 4, negative 15, here we go. Negative 4, positive 15. Those sum to 11. And those are our winners. Winner, winner, chicken dinner. And so, we're going to split that term 11x into two pieces, minus 4x and plus 15x. Hard part's over. Now just factor by grouping. Out of our first two terms, we're going to factor out 2x times 5x minus 2. From the second two terms, factor out the common 3. 5x minus 2, and then factor that common binomial 5x minus 2 to the front, times 2x plus 3. And we see the same factorization as we saw before. Now, as you all are factoring trinomials, and it really doesn't matter what method you choose. You know, if you're comfortable with trial and error, stick with it. If you're having trouble with trial and error, we've got this alternate method for you to fall back. Let's work another. 6a squared minus 5ab minus b squared. Our outer product, 6 times negative 1 is negative 6. And let's speed up a little bit here. Factors of negative 6 that sum to negative 5 are negative 6 and positive 1. So let's rewrite as 6a squared minus 6ab plus 1ab minus b squared. Hard part's over. Factor by grouping. Factor out 6a times a minus b, and factor out b times a minus b, and pull that repeated binomial factor a minus b out to the front, times 6a plus b. And we see the same factorization as we found previously. Notice that it doesn't matter what order we write those factors in. Multiplication is commutative. And lastly here, hopefully you're getting good at these, feeling more comfortable now. As we multiply those outer coefficients, that product is 20. Now we're looking for factors of 20 that sum -9, so they'll both be negative, don't they? Like -1 times -20, -2 times -10, no, -4 times -5, and there's our winner. Rewrite as 10x squared minus 4x minus 5x and plus 2. And again, all we're doing here is writing our first term, writing our last term, and splitting that middle term into pieces. And then we factor by grouping. Factor out common 2x times 5x minus 2. And to repeat that binomial 5x minus 2, we need to factor -1 from our last two terms. And finish the factorization by factoring 5x minus 2 to the front, times 2x minus 1. And again, remember to check by multiplying it back. But we know this checks. We checked it previously. So again, there you have your two methods, trial and error versus the method 2, which goes by many names. We might call it factoring by grouping. Some would use the acronym MARF. Now let's look at example 2, where we want to factor completely. And we do always want to look for a greatest common factor when factoring. And these three terms are all even, so we know there's a common factor of 2, and they all three contain x squared. So let's factor out 2x squared times 14x squared minus 29x minus 15. Now when you continue your factorization, no matter what method you use, don't let that greatest common factor disappear, okay? It is indeed part of the factorization. I'm going to use trial and error. And for factors of 14, I'm going to start by trying the combo of 7x with the 2x. And for factors of 15, I'm going to try to combo a 3 with a 5. If we try a 3, then a 5, we've got 21x with a 10x, and we know these have to be differently signed. So one of these is positive, the other negative, and there's no way to combine a 21 with a 10 via subtraction and obtain 29. That's not going to work. So what if we switch our 5 and 3? Okay, that's going to give us an outer product 6x, inner product 35x, and we can use these to obtain 29 if the 35 is negative and the 6 is positive. So let's make the 35 negative, the 6 positive, and quick check. First product 14x squared, 6x minus 35x is negative 29x. And lastly, we do obtain negative 15. So that's going to check out just fine. Yay! Let's see, last problem, part B. Let's start by factoring out the greatest common factor, which is k plus 9 to the 7th. We see that in each of these terms, don't we? Now, what remains? 4t squared plus 20ts plus 25s squared. And let's continue factoring if possible. And what we see as our trinomial here is actually a perfect square trinomial. And we can recognize that perfect square trinomial because its first term is a perfect square. 4t squared is 2t times itself. Our last term is also a perfect square. 5s times 5s gives 25s squared. We know to use plus symbols because we have all positive terms. And then let's check and make sure this is going to work. 2t times itself is 4t squared. Outer product, 10st. Inner product is the same. 10st, or you might say ts. Combine those to 20ts. And lastly, 5s times itself is 25s squared. In this video, again, we have factored trinomials that have a leading coefficient that's a number other than 1. These are challenging. Take your time. Use whatever method that you need to use, and always check your answer.